So, hello everyone. Thank you for joining this web conference organized by the Toulouse School of Aviation and Aerospace Engineering. It's a collaboration between ENAC and ISAE-SUPAERO and the team Research, Innovation and Training Supporting Aviation Sustainability. It's held on the occasion of the launch of the Advanced Master 100% online in sustainable aviation. I'm Marie-Pierre Cassagne. I'm a member of the Transitions Project team at ENAC, and I will be hosting the event today. So to ensure a smooth flow of this session, your microphones and cameras have been switched off. However, you are able to ask questions, and you are welcome to do it via the chat. One or two questions will be passed on the speakers at the end of each presentation, and this session is recorded. Let us now turn to the agenda of the web conference, which will last 1 hour. We will begin with a recorded introduction by the president of ISAE-SUPAERO, followed by a presentation by Laurent Joly on the role of research in the transition of aviation sector. Joseph Risson will then highlight the impact of innovation before Isabelle Laplace and Nicolas Gourdin explain how education addresses these challenges. Finally, a recorded message from Olivier Chansou, President of ENAC, will conclude the session. We would like to warmly thank our speakers for their active participation. Thank you all for your interest and attention. So let's start with the video of Marie-Hélène Barou. As the introduction of this web conference, Marie-Hélène Barou, the President of ISAE-SUPAERO, wished to address the message to you.
Welcome everybody. My name is Marie-Hélène Barou. I am the President of ISAE-SUPAERO, Engineering and Research School on Aeronautics and Space Science in Toulouse. I am delighted to welcome you to this web conference, Research, Innovation and Training Supporting Aviation Sustainability. Thank you for joining us today. Aviation sustainability is a collective challenge, and this web conference is an opportunity to share information and different perspectives for those who wish to engage in this field. Together with ENAC, our partner, also Engineering and Research School in Aeronautics and Aviation in Toulouse, ISAE-SUPAERO has developed an expertise which is internationally recognized, especially by industry and certification authorities, in three complementary areas: research, education, and innovation. We are going to address these three dimensions in our discussions during this web conference. Let me start with research. Research is central to both institutions, ENAC and ISAE-SUPAERO. And we have joined our forces to direct part of our scientific research towards sustainability, notably through the creation of the Institute for Sustainable Aviation, ISA. The objective is clear: to develop interdisciplinary research that can support the transformation of aviation in and for the future. Some of you may already be familiar with our current research work. For example, AeroMaps, which is a specific software tool, free tool, focusing on prospective scenarios. This tool has been designed to reduce air transport impact on global warming regarding the various effects of climate change and economic or social parameters. As you can see, our research activities and projects linked to sustainable aviation are specifically designed and developed by bringing together a wide range of disciplines such as economics, engineering, law, and the social sciences. Actually, and I am sure you understand, complex challenges require integrated approaches. And our speakers later on during this web conference will develop precisely many of these topics. Now let me present the second pillar of our action. Education is naturally the core of our activity in ENAC and ISAE-SUPAERO, as you know. Our both institutions offer high-level engineering programs based on an interdisciplinarity approach and aligned with current and future skills. Sustainability has now become a central component of these programs. By integrating environmental sciences and humanities in our courses, we aim to strengthen critical thinking and prepare our future engineers and scientists to design solutions in regulated, complex, and uncertain environments. During the conference, you will see all these aspects developed by our speakers. Finally, and before the conference, let me say a few words about innovation. When we talk about sustainability, we should not forget that innovation has an important role to play. Innovation could be considered as a bridge between research and education and the realities and the needs of the world where we live. The real world realities, in short. ISAE-SUPAERO and ENAC support and host several high-potential entrepreneurs from our students and from faculties members, and invest internally to continuously renew teaching contents and practices related to innovation. Several startups focusing their activities on sustainability are being incubated within our ecosystem. We have also launched a new fully online and asynchronous program on sustainable aviation designed especially for international and intercultural audiences. This program has recently been certified for its high quality, based on the latest scientific knowledge on innovating teaching methods. This program develops an approach that resonates strongly with the topics we will explore together today. I hope this brief overview helps set the stage for further discussions with us. Now, I invite you to engage, exchange with our speakers, ask questions, share your perspective through the web conference. With that, I hope you will have a nice conference.
And now, Laurent Joly will talk about research in sustainable aviation. Thank you, Laurent.
Thank you. Thank you to Marie-Pierre and Matthias for this introduction. So I will open the round of this web conference with a focus on research, one of those three pillars of our raison d'être. I will address the role of research in the contribution of the Toulouse School of Aviation and Aerospace Engineering to the transition towards sustainable aviation. And I will get straight to the point in 4 slides and 4 key messages. First message. Responsibility and systemic challenge. The alliance between ENAC and ISAE-SUPAERO within TSAAE provides indeed a relevant framework to address one of the most profound challenges facing our sector, the transformation of aviation to sustainability. This transformation is systemic. It concerns propulsion technologies, of course, aircraft architecture, operational concepts, energy pathways or economic models, and of course, regulation and regulatory frameworks. And it will reshape not only aircraft and how they are designed or operated, but it's the entire aviation system that will evolve over the coming decades. And in this context, research carries a particular responsibility. That was the point I wanted to insist on that slide. And as academic institutions deeply embedded in the aviation ecosystem, we of course contribute to the scientific foundations that inform industrial strategy and public policies. And in this respect, sustainability must therefore be addressed with rigor, transparency, and long-term analytical ambition. That was the first of my messages. The second one, historical legitimacy of ENAC and ISAE-SUPAERO. Of course, the engagement we are speaking of today builds on a long-standing trajectory. For decades, ENAC and ISAE-SUPAERO have contributed to advances in aircraft design and air transport operations. Through a combination of fundamental research and close collaboration with industry and public stakeholders, our institutions have supported improvements in safety, efficiency, performance, and competitiveness. These contributions were not limited to incremental advances. They have also included methodological innovations, modeling solutions, breakthrough concepts, and systems approach that have helped shape both technological development and operational practice. Today, the sustainability transition expands both the scope and the complexity of these research questions. Decarbonization, resilience, competitiveness, and sovereignty must now be considered simultaneously. The third message. It has been a little bit advocated by Marie-Hélène in her video. Interdisciplinarity. This is really key to what we're bounded to do now together with ENAC in this alliance we are announcing today. Sustainability cannot be addressed within disciplinary boundaries. The Institute for Sustainable Aviation was precisely created to address this question beyond disciplinary boundaries. Engineering science must interact with climate science, life cycle assessment, economics, law, and governance. At the same time, research must remain closely connected to manufacturers, airlines, ANSPs, energy providers, even financial actors and public authorities. With TSAAE, we pursue both fundamental interdisciplinary research and collaborative projects with stakeholders. It's through this interaction, of course, that between disciplines and the stakeholders that research is going to generate impact. And that's the key word on that slide, impact. Research with impact. And TSAAE enhances our capacity to contribute to the broader collective dynamics in which we are engaged within the Institute for Sustainable Aviation, together with the other members, of which the logo are present at the bottom of the slide. So that was the third message. And the fourth, not the least, prospective tools, translating research into strategic guidance. That's really important. That's more or less the thing that we're doing on the ground of research, because the transition to sustainable aviation unfolds under significant uncertainty. Technological maturity, energy availability and cost perspectives, regulatory evolution, and demand trajectories remain open questions. That is for sure. And these are all causes of uncertainty. And in such a context, research must also provide perspective tools capable of informing strategic reflection. And this is the rationale behind the AeroMaps platform you may have heard about. You can see the logo on my slide. This platform is designed as a platform to build and compare aviation transition scenarios, integrating state-of-the-art models, scientifically validated, peer-reviewed, and ensuring transparency of assumptions. That's very important. You can generate any scenarios switching from one assumption to the other one. In the context of AeroMaps, everything is clear and announced and transparent, and even the content of the models is open, so that there is no doubt about what is going on in that platform under the surface, you may say. So that platform aims to provide a shared analytical basis for both industry decision makers and public governance bodies. And such initiatives illustrate how research can function as a common resource within the broader Institute for Sustainable Aviation, by clarifying trade-offs, timelines, and leverage points in systemic interactions. Research supports informed decision-making without prescribing a single pathway. And I come to my conclusion. The to say again that this alliance between ENAC and ISAE-SUPAERO within TSAAE reinforces our ability to produce rigorous, interdisciplinary, and impactful research. The academic foundation contributes to the wider collective ambition of advancing sustainable aviation. Thank you, and I am open to questions if there are.
Thank you very much. So, is there any question? Don't be shy if you have any question to give us. So I don't see anything. So okay, thank you.
I must have been clear.
Exactly, it was exceptional. Thank you very much, Laurent, for this presentation.
Thank you.
So research now fuels innovation. And now let me introduce Joseph Risson, which is co-founder and president of Virage Aero, and who will highlight how innovation can already deliver tangible impacts for the transitions of the aviation sector. Thank you, Joseph, for joining.
Thank you, and thank you for the introduction.
You're welcome.
So, yes, good morning, everyone. I'm Joseph, co-founder of Virage Aero. So, ENAC and ISAE-SUPAERO team asked me to join this webinar to illustrate how important innovation is in aviation. So, in order to illustrate it, I'll try to present what we're doing. To give some context, I've started Virage Aero as a student when I was at SUPAERO, and now built a company around the project. It's been mentioned, sorry for the colors are wrong, it's the PPT mistake, but it's been mentioned, everyone here is familiar with the problem. Aviation needs to decarbonize in quite an urgent way. It's the fourth revolution of aviation that's needed. And there are some potential solutions. And sadly, there are only partial solutions, and they all take time. It's the way aviation works. On top of that, efficiency gains have already been pushed very far after years of optimization, but traffic is growing faster than efficiency improvements. Fossil fuels will become less available, SAFs are highly demanded, expensive, and non-CO2 effects are still often placed in the background. There are many challenges for aviation to continue. Laurent has also shown that before: social problems, technical problems, energy, infrastructures, and problems call for solutions which often call for innovation. But my goal here is to focus in the project on technical problems. So from an energy and technical economic perspective, we need solutions that enhance efficiency beyond the efficiency plateau existing turbines are now reaching to make SAF economically viable. And the second point is to reduce non-CO2 effects and not only the fuel burn. And all this in a short time frame, which is not compatible, of course, with aviation. At Virage, we develop a tech that cuts fuel burn by 30% and tackles also the non-CO2 effects. It's called steam injection. It's a principle widely used for ground-based applications for electricity production, for example. It's part of a combined cycle designed to recover heat that would be usually lost in the atmosphere. So if water is available, this water injection can be used to generate steam, which is resulting in more power, more efficiency, and less NOx and less contrails. So on paper, it's a very attractive principle, of course. However, it requires water. So on the ground, for ground-based application, it's easy. You open the tap and you have water. For airborne applications, carrying water tanks are too heavy. So what we do at Virage, it's that we recover water in the exhaust gases. Water is available, and we condense it, we inject it again. Okay, so it's a closed loop cycle, making it possible to develop the first steam injected turbine for airborne application. So now that was the technical side of innovation. I've got another illustration because that's my goal here today, to illustrate as much as possible, but rather on the approach. Because building projects like this that can potentially reshape a sector is what most entrepreneurs look for. But aviation is one of the most challenging sectors to innovate in. It's highly regulated, development times are long, certification timelines are long, the capex barrier is very high. We need engineers, fleet renewal, the cycles are slow, and we need credibility also, which is strongly linked to the age and track record of a company, which is not our case since we're 2 years old. So it's really not ideal ingredients for fast iteration and innovation. Nevertheless, we chose to address it, and we had to find a path. So we based our approach to overcome these difficulties. Instead of developing a turbine engine from scratch, we modify existing engines. Our steam injection module can be installed on existing and certified engines, meaning less development times, lower capex, shorter certification timelines, and with comparable performance levels. So all this for faster adoption. And this kind of way of thinking of fast iteration and innovation we've done also in our way of engineering our development, since we all are all in the same spots, like the engineering zone, the test zone, mechanical zone. We all are 3 meters apart, so we can iterate as fast as possible to reach to develop the technology. And I think this closed loop cycle is really important for our development. So yes, as mentioned at the beginning, I was invited here to illustrate innovation. Hope I've illustrated good enough. Our project is quite particular because it combines both technical and approach development innovation. But I'd like to conclude by linking this to the importance of embedding this mindset in engineering educations, especially at ENAC and SUPAERO, because aviation was one of the most fertile sectors for innovation during the last century, with at the very early days of aviation, like hundreds of iterations, testing many architectures and continuously pushing the boundaries, with the associated risks, of course, and deaths. And that is what is making aviation what it is today. Today, the level of system complexity, of optimization, of regulation, and the capital risk associated with any decision makes it much more difficult to innovate. So most engineers trained at ENAC or SUPAERO will join large industrial groups, and the scale of the transformation requires for aviation to approach to approach this net zero objective, the 2050 net zero objective, demands, of course, out of the box thinking. So especially in these large OEM that have the power to make a difference. So achieving this aviation transition would not only rely on a single breakthrough, though I really think steam injection is the way to go, but it's been mentioned by Laurent, it's interdisciplinary. It relies on the collective ability of engineers, researchers, and decision makers to continuously innovate, deploy solutions, and push the boundaries of what is considered possible in this highly regulated industry. And my final point is that this mindset must be built at school and carried into the workplace. So I see innovation courses at SUPAERO and ENAC taking more and more space in the curriculum, and I think it's excellent. So thank you, and if you have any questions, I'm of course here.
Thank you very much for this very interesting intervention. So I have a question for you, Lucky. How did you get this idea? Which was the trigger of your involvement on sustainable aviation? In fact, it's more 2 questions.
So the second question, the trigger is that actually always wanted to be an aeronautical engineer since I'm 10 years old. but the climate urgency of the sector came in my way, so I couldn't just join a larger OEM and do the normal engineering quest. So that's how I started this project and tried to find a way to find a solution. And back to the first questions, the idea came from this. So I tried to I had previous experiences in hydrogen propulsion like projects, and fuel cells were too heavy, turbines were not efficient enough for hydrogen, so try to find a way to make it work together in a synergy way, and steam injection came into mind because fuel cells have a lot of water that can be put in turbines. So that's how.
Thank you very much. I think there's no more question today. Are you sure you have not a question? Well, anyway, we could. So I will then give the floor to Isabelle Laplace and Nicolas Gourdin. And so research, as we see, enables innovation to grow and to enrich education. So while education provides the skill innovation needs to address the role of education, I am pleased to hand over to Isabelle, which is co-head of the Prospective Division and Sustainable Aviation in ENAC, and which is head of NovaAero Share on Education to Aviation Sustainability. But she's also associated researcher at ISAE. So, and then Nicolas Gourdin, which is professor head of education program in sustainable aviation at ISAE-SUPAERO. They will show how sustainability challenges are integrated at all levels of training in both institutions and will introduce the Advanced Master in Sustainable Aviation. So the floor is yours, Isabelle. Thank you.
Thank you very much, Marie-Pierre. So yes, today I propose you to present you what we do at ENAC for students, generally speaking, with the aim, of course, to train them on sustainable aviation, because this is at the heart of our mission. We consider that training them, they can be students for initial training, or they can be working professionals. But we estimate that it's in our mission to tackle them, to be able to tackle, the aviation sustainability challenges. And that is why, in fact, I propose to share my presentation in two parts. First of all, we talk about what we do, what we're doing for initial training, so for a lot for every student, and I will make a focus on engineer students. And secondly, we talk a little bit about working professionals, and also some example of what we propose for them for the trainings. So let's start with initial trainings. And at ENAC, we maybe you don't know, but in fact we have a lot of different categories of students. We have, of course, engineers, but we also train air traffic controllers, pilots, technicians, and so on. And so when they come, they do not have the same knowledges or competencies or skills about environment and the link with aviation. And so we consider it's really important to provide them common knowledge and skills about these topics. That is why they all follow together a common module of 1 week module, with workshops, conference, or e-learning sessions. And the objective of this common module, so they are all together, is for them to have a comprehensive and systemic understanding of the link between aviation and climate change, for instance. Second, to identify key decarbonization levers. They can be already implemented, or they can be considered by the sector. Also, the third objective is to develop their behavioral skills. And so this, I say they're all together, and they work most of the time in group. And one of the delivery of the week is for them to work in group, and the group are mixed between the different categories of students, controllers, engineers, and so on. So they have to think about and to propose the vision of air transport in 2050. From 2022, we estimate that there are more than 1,800 students that have already completed this module, and it involves a lot of person in ENAC. And now let's have a focus for engineer students with examples of what we propose to them in terms of module. We have, because it's of course important for them to know what is research, but applying this research to aviation sustainability is an asset, in fact. And so we have designed a model that helps to bring both. So for the students, the objective is to design and implement a research program that address a certain topic related to the ecological transition of air transport. These topics can be varied and with different scientific disciplinary and so the role of researchers is to accompany the students and for them to discover what is research and to apply to the specific case of that aviation sustainability. Second, we are building new models that will be proposed to students next year about the introduction of low carbon aircraft in the air transport system, because it leads to several questions, and so it's something that is built in the scope of the Pegasus project, in which there are other partners, and ISAE-SUPAERO is of course one of the partners, and this project is funded by the French Agency for Project-Based Research Funding. And a third example of what we can propose to engineers is a model dedicated to societal challenges of air transport. This model is opened to all students from the ISAE group, and during 1 week, the students, the participants, are there to develop to increase the awareness of the complex interaction that can exist between air transport and society, and to link the future of aviation with the future or the evolutions of societies. One specificity of this module is that it's built so as to implement active and experiential teaching methods. For engineer students too, we will propose from next year a new model which gives them the ability to get a certificate, which is called Novaero certificate model. It will be 75 hours to prepare them for the future jobs, in fact, because they are future professionals of the sectors, and this when they will be professional, they will have to industrialize and develop the sectors, and in fact, this development, the role they will play will be in multiple contexts. They can be operational, societal, economic, environmental, and so on. And so the objective of this module is to help them to consider all this context, of course, with the respect of planetary limits, and this module is built in the scope of the Novaero chair. So it's a chair. Marie-Pierre explained that I'm the head of this chair, and we have two sponsors, Airbus and Air France. And so the objective of this module are various. First of all is, of course, to provide essential knowledge and skill that we consider that as needed to design and develop sustainable and responsible aviation. So it will lead to the delivery of a certificate, and this certificate can make the difference with other candidates to different jobs, of course, in the future. It will in this module we'll also have the intervention of several companies, and so this means that for students they will have a privileged access to internships, final year projects, and of course job opportunities at the end of the day. In this module, the certificate, we will of course combine scientific foundations with practical case studies. And these case studies will be on current challenges that face the sectors today. And we will implement active and experiential teaching. We privilege this kind of teaching methods. Then let's talk about what we propose for working professionals. For years, of course, we develop training for working professionals so as to help them to get specialization when they need for their job. And in the scope of airport, we propose some training specialized on the link between environment and airports. For instance, this one is 3 days, and the objective for the participants is to provide to the participants some knowledge on the environmental impacts of airport operation on surrounding areas. Maybe it can strengthen this knowledge, and then to provide them an overview of the environmental policies of French airports, so as them to be equipped with technical guidelines and key messagings on current and future challenges. Another illustration of what we can propose to working professionals is a 3 days module to train them about energy transition at airports. The objective then is to provide them general knowledge, but also best practices to help them in their infrastructure to deploy some infrastructure, but also to deploy some equipment solution on their platform. And in the scope of this 3 days module, there are a lot of different experts that are involved and that intervene. And at the end of the 3 days, there is a workshop based on real life case studies. And to finish, and I will not make a long presentation on this because Nicolas will more explain this master program dedicated to sustainable aviation that will be launched from September, next September 2026. It's a master program built together between ENAC and ISAE-SUPAERO in the scope of the TSAAE, so Toulouse School of Aviation and Aerospace Engineering. And the objective is to give the skills, the knowledge, as well as systemic visions that will make all these trainees key actors of becoming sustainable aviation. So I think it's a last slide for me. I will be happy to answer question, or maybe Marie-Pierre, do you want the question, or just after the presentation of Nicolas, maybe, I don't know.
So now there's a first question, which is it open to graduate from business school? So HAC, ESSEC, ASPCP, and not only to engineers?
Which one, sorry?
The master, I would expect. The MSSA.
Oh yeah, this one. Okay.
Yeah, exactly.
So I think that this master is open to everyone, but Nicolas will give more explanation. But of course.
Yeah, I think we will have more explanation about the master in a second. So I think it's the only question for you, Isabelle. So thank you very much for a very clear information about what proposed ENAC in this topic. And I will hand over to Nicolas. So Nicolas, could you... Oh, there's another one. Sorry, Maël, we will take your question just after Nicolas' presentation if you want. Okay? So Nicolas, please.
Okay. Yeah, you can hear me properly?
Yeah.
Yeah, perfect. Thank you. Good morning or good afternoon, everyone. So my name is Nicolas Gourdin. I work at ISAE-SUPAERO, and I'm leading a new advanced master program about sustainable aviation together with my colleague from ENAC, Jean-François Véron. Most of my research today deals with the impact of climate change on aviation, as well as to look for some optimal scenarios to decarbonize air transport. So let's just to start with one of the motivation for this topic. The idea is to address some of the vulnerabilities of air transport. There is a high dependence to liquid fossil fuels of air transport, for which the long-term availability of these fuels is not guaranteed, especially at a cheap price. There are also some physical risks, especially if we consider the impact that climate change can have on aviation. So the idea is not to develop everything here, but just to mention some of this risk. You can have the impact of heat waves that reduce the density, the air density, so it increase the length of the takeoff distance you need to take off in good conditions. You can have an increase of probability of clear air turbulence as well as its magnitude. So it can raise some questions about the safety for some flights. You can have also some risk, particular risk we call transition risk. Let's just mention one particular risk. If you take, for example, the automotive market in France, 10 years back, 70% of the car sales in France were based on diesel engines. Today, it's less than 5%. So in less than 10 years, dominant technology was replaced by something else. In this case, mainly electric cars or hybrid cars. So the idea is to address also this very specific category of risk that can disrupt the air transport within the next decades. So Isabelle Laplace presented all what we can do about education on these particular topics. I mean by that sustainability, especially for initial training. But I have to say that very little was done in the past for executives and professionals of the aeronautics sector. Especially very little was done by academics for the professionals. So it's a pity since the knowledge about sustainability is progressing extremely rapidly. And we are understanding more and more about the relationship between climate change and air transport. We are understanding more and more about potential alternative energy carriers. We are understanding also more about the relationship between air transport and the availability of some resources like metals or energy as a whole. And so this is mainly this aspect I would like to develop within the next few minutes. So based on the rigorous scientific approach, we are pleased to present an answer to that question. So it's a new master supported by the Toulouse School of Aviation and Aerospace Engineering about sustainable aviation. And this advanced master degree combines the knowledge on sustainability available within the industry, led by industrial experts, with the best of academic knowledge available in academia. Laurent Joly mentioned it also for research, but for these questions, the interdisciplinarity is at the core of the issues. And so it should also be the case for education programs. Typically, the decarbonization And as a general manner, a better account for the environment in the development of air transports needs to activate several levers and hold these levers at the same time. Not just technical levers, it's one of the categories that should be activated, as presented by Joseph Risson, for example. But we have to combine these technical levers with economical levers, which is clearly a part of the sustainability concept. And it should be combined with regulations that defines the common playground for all actors, as well as politic levers for the narratives. And so it's exactly what we intend to do in this program. This interdisciplinary program combines aeronautical engineering, manufacturing, and industrial production, climate change, and relationship with aviation, as well as air traffic management or regulations and so on. So this program is conceived for an international audience, 100% in English, 100% online, mainly asynchronous, and only 15% of the program is synchronous. So it has been designed for executives and professionals of the sectors to make it compatible with a complex schedule for this particular audience. All the program will be fully online on an online campus, designed in secure digital environment. It's based on a blended learning approach. So it combines multimedia, micro contents. I will show you a very quick example just after that, with webinars, case studies, collaborative projects in professional context, and interactions with experts. The program rely on online courses, about 450 hours spent on 10 months. So it represents approximately 10 hours, a bit more than 10 hours of work each week. And it will be completed by an internship with a professional thesis that will last 4 to 6 months, full-time equivalent. The program is designed around 4 competencies. The first one is the ability to assess the environmental impacts of products and services related to air transport, with the objective to identify co-design levers, especially through life cycle analysis. The second competency is to design some technical organizational solutions to improve the sustainability of these products and services. If it's unclear what we mean by organization, you have just to think to what Taylorism or Fordism is. There is no technological revolution associated to that, but it's clearly a revolution in the way to produce. So this is for the second competency. Then the 2 last one are, first, the ability to analyze complex situations and design prospective scenarios based on a systemic approach. And the last competency is to support the implementation of innovative solutions within the organizations, while taking into account for certification constraints, for example. All these competencies will be developed and certified through 4 different interdisciplinary projects that involve questions about the design of drones, some situations about air traffic management around an airport, or the implementation of breakthrough technologies for aircraft, as well as the design of perspective scenarios to imagine a roadmap of transformation for an airliner, for example. We are dealing with 7 different disciplines as aviation and environment. So it includes climate, resources, and some questions about water or biodiversity. We are dealing with certification, eco-design, energy, including alternative energy carriers like hydrogen or sustainable aviation fuels. We will deal with digital technologies, system approach, and innovation. So I have to end my speech, but I would like just to show you some examples of the levers we are studying in this program. As you can see, we are considering most of available levers to reduce the carbon footprint, but the environmental vulnerability of aviation. You have fleet efficiency, breakthrough innovation, work about alternative energy carriers, but also policies and regulation, individual behaviors or economical levers. So we are considering all these categories of levers to make aviation more sustainable. Some of the courses are done by most of the courses are done by professionals of the sector, like for example Céline Demouge, who is engineer at the Directorate General for Civil Aviation, so the French Civil Aviation Authority. She's giving a course about contrails. We have courses from internationally recognized experts, like Stéphane Gosling from the Linnaeus University that deals with tourism, for example. And we also have some interview with professional of the sector like Olivier Canal from Airbus. So I end my speech here, but I would be happy to answer questions about this new innovative program at INAC and ISAE-SUPAERO. Thank you.
Great, thank you very much, Nicolas. So you have plenty of different questions. The first question is it a possibility of work studies system in the formation? So in this master, I suppose it's on the master, it's Maël that asked the question. So
I'm not sure to understand what you mean by
work studies. Okay, I think that for me it's the possibility in the same time to have part-time work and to do.
Yeah.
I'm not sure this is the question.
If it's the question.
Yes, she said I meant the alternance. So is it possible to do in alternance? To be alternate?
That's a good question. At the moment, it has not been. This possibility has not been investigated. The idea was more to start the internship in January or February, while the program in itself is starting in September, end of September. So it's not exactly alternance, but maybe we can discuss that point. It's a very good question.
Thank you. Another question was from Mohamed about how to apply and how to be helped. So for that one, I have normally you see, if you see in the screen, you have all contact to be helped to really apply, and you can write to this email, and you will have some people who help you to apply on the program. No problem. And then
you can apply all the year till August.
Okay, so you are not late if you want to apply.
Right on time.
Exactly. The next question is how is assessed the accomplishment of this program and the thesis? So in fact, on the program side, so on the training side and on the thesis side.
Okay, it's a large question. First, about the academic part. The first part, we have modules that are evaluated through different exams or practical case studies. And then you have the competencies. The competencies are mainly evaluated through projects. You have projects that give you a professional that are based on a professional case study, and then at the end of these projects, you can have different way to evaluate it through defense or some report, or we try to imagine some innovative way to like maybe you know the Pesha Kucha, for example. It's a way to propose a speech, a very short speech, and this is a way to evaluate it. And then of course we have some classical exams also. So this is for the academic part, and then for the internship, you have to produce a professional thesis, and then there is a defense.
Okay, very good.
In front of a professional jury.
Yeah, we have plenty of questions, and it's already one. So I think we, of course, don't be mad. We will answer all the questions. You will receive an email with all the answers that of your question that you have on the chat right now. No problem. And anyway, if you had not time to ask your question on the chat, you can write us, and you can provide us some questions. I would like that now to hand over to have the video of Mr. Chansou.
Good morning, everyone. Thank you for joining us today for this web conference on research, innovation, and training supporting aviation sustainability. I am Olivier Chansou, President of ENAC, École Nationale de l'Aviation Civile. ENAC raison d'être is to train the best professionals in air transport. In our school, we train engineers, air traffic controllers, pilots, and other professions that all contribute to the aviation sector. Aviation is a very complex system, a system of systems that requires a holistic approach to understand challenges, to understand how it works, and how to prepare its evolution. With ISAE-SUPAERO, our strengths are highly complementary. We have therefore created Toulouse School of Aviation and Aerospace Engineering, which aims to promote our expertise and training programs. They cover all the spectrum of aeronautics and aviation. They are designed for students from all over the world. We have also joined our research strengths and created a joint research laboratory, TSAAE Lab, able to address all the key challenges facing aviation. In particular, its transformation into a sustainable aviation. This lab is one of the leading players in aeronautics and aviation research at European level, with almost 500 people involved. As you have understood, the aviation sector has committed itself on a strong and clear path toward decarbonization by setting ambitious targets, including net zero emission by 2050. This trajectory must be part of this global, systemic, and global approach I mentioned. It has to take into account the fundamental values of aviation, such as safety, of course, openness. It must enable transformation of aviation in order it remains the safest means of transport in the world, able of opening up the world by connecting people from all continents and countries, which is particularly essential in today's world and in the future. Aviation sectors need to find women and men who are capable of understanding all these issues and their interaction, who have the necessary knowledge and skills, who have also the global vision to be the drivers and key players of the transformation of aviation to a sustainable aviation. In our school, we have therefore implementing a common foundation of knowledge and skill relating to the ecological transformation of aviation in all our training courses for several years. Today, we are launching a new and remarkable product, MS Sustainable Aviation, which, as it was indicated, is based on the latest scientific knowledge and most improved educational innovation. This program has been developed to meet the expectation of the sectors. It has been developed with professionals coming from these sectors and aims to provide the same sectors with trained and committed talent for the transition. I hope that today's webinars have given you a better understanding of the challenges facing sustainable aviation and how we need to prepare to meet them. I hope it has inspired you to become one of the key players I already mentioned. We remain at ENAC and ISAE-SUPAERO at your disposal for any question or further information you may require. Have a great day. See you soon. Thank you.
First, I would like to thank really all the people who has participated to this web conference. The subject is current, it's forward-looking, and it's strategic. And the environmental transition of the aviation sector is vital to ensure we can continue connecting people around the world. So thank you all for your interest in this very important topic. And we will have also a masterclass in a few months, so we will let you know when it is. And thank you very much for your attention throughout this discussion. Many thanks to all of you. Thank you. Bye.